In this video we're going to look at the line AB. Line AB starts at coordinate minus 5, 2 and ends at coordinate 5, minus 6. And we want to find the distance of that line. And the second part of it is then we want to find the middle point of that line. We start with the distance. What we can't do is just measure the distance with a ruler. Okay, we can't do that because we're not dealing with centimetres here, we're dealing with units. So what we're going to do is we can use this formula. This formula is straight out of our log books. We don't have to learn off by heart or anything like that. Basically what this formula does, this formula is just another version of Pythagoras' theorem really. So what this formula does is it looks at the distance from A all the way over to here, and then B all the way up to here. And it basically makes a right angle triangle. And then it looks at this distance and it looks at this distance. And remember, in a right angle triangle, the opposite plus the adjacent, the opposite squared plus the adjacent squared equals the hypotenuse squared. So if we square this length and this length, we're going to get the square of this length. Alright? So that's really all it does. So in order to solve this question, you could actually use Pythagoras' theorem if you didn't want to use the formula. Anyway, I'll just use the formula. So what we do is we take our 2 points. So we'll take A first. So A is minus 5, 2. And B is 5 minus 6. Yeah. So first step, write down our formula. Second step, write down our coordinates. Third step, label our coordinates. x1, y1. Remember the x comes first. So x1, y1. Next one is x2, y2. And all we do then is we take our formula and we plug these points in wherever we see x1 or x2 or whatever. So t equals the square root of now x2 is the 5. So bracket 5 minus x1 is minus 5, so minus 5 squared plus y2 is minus 6 and minus 2. That's all to be squared. We could throw it into our calculators and it'll give us out an answer, but let's just do it out. So 5 minus minus, well that's 5 plus 5 to be squared, and then we have minus 6 minus 2, which is minus 8 squared. So d equals 10 squared plus 10 squared is 100. So 5 plus 5 all to be squared is 100, and minus 8 squared is 64. So d equals the square root of 164, and that is 12.8 rounded to 1 decimal place. Okay, so that's how we get the distance. The next one is the midpoint. So how we get the midpoint? Similar really. We have a formula. It's in our logbooks. We don't need to know it off by heart. We just check it from our logbooks. We write down our points again. Minus 5, 2. 5 minus 6. We label our points. x1, y1, x2, y2. We slot them into the formula. So x1 is minus 5 plus x2 is 5 all over 2, comma, y1 is 2, y2 is 6 all over 2, minus 5 plus 5 is 0 over 2, 2 minus 6 is minus 4 over 2, and that will give us 0 minus 2. So there is a midpoint. Okay, and we'll just have a look here. 0 minus 2, where is that? 0 minus 2 is here. Okay, and that looks the midpoint. Okay, so that's that done. Yes. Right, now here's an interesting question. It says prove that the point 0, minus 2 is in fact the midpoint of AB. So we're after finding the midpoint of AB here, based on this formula. But how do I know it's true? But how do I know it is the midpoint? There is a method of proving it's true. What if I got the distance between here, the midpoint, and B, and then got the distance between the midpoint and A? If that is the midpoint, well, surely the distance between here and here and the distance between here and here will be equal. Okay, so all we do is we get the distance between this point A and our midpoint, then we get the distance between this point B and our midpoint, and see if they're the same. Right, so the first point is minus 5, 2. Okay, so that's point A. And I'm going to get the distance between that and our midpoint. So we use our formula, x2 minus x1 in brackets squared plus y2 minus y1 in brackets squared, and that's distance equals that. Label my points x1, y1, x2, y2. Throw them into the formula. Okay, so slotting in our points, then we have the square root of x2 is 0 minus 5, which is plus 5, that's all to be squared, plus y2 is minus 2, and then y1 is 2, so it's minus 2 squared, and that gives us 5 squared, which is 25, plus minus 2 is 4. Sorry, minus 2 is minus 4, and minus 4 squared is 16. And that is 41. Square root of 41. Okay, I'll leave it at that. I'll leave it at the square root of 41. I'll go over here. Again, where midpoint is 0, minus 2. Our point B then is 5 minus 6. 5 minus 6. Label them x1, y1, x2, y2. Throw it into our formula. So x2 is 5 minus 0 squared plus, and then we have y2 is minus 6 minus 2 squared. That will give us 5 squared plus, and we have minus 6 plus 2 squared, so 5 squared and minus 4, so plus minus 4 squared, which gives us 25 plus 16, which gives us 41. They're both the same, so we can say square root of 41 equals square root of 41, therefore 0 minus 2 is the midpoint of the line AB. Okay, thanks.